Here are the solutions for the page 143 second homework assignment, beginning with number 17, where we're asked to solve the equation. I'm going to subtract 7 from both sides, making negative 2x is equal to 8, then divide by the coefficient of negative 2. 8 divided by negative 2 is negative 4. Remember, you can check that this is correct by substituting in for the letter x, evaluating this to make sure it makes 15. On number 21, it looks like doing the distributive property would be a good first step. This becomes 2x plus 10. Here's the minus 7. And on this side, some more distributive, 3x minus 6. Then we could do combining like terms on those two. So this is 2x plus 3, and that's equal to 3x minus 6. Let's collect the x terms on the left side by subtracting 3x from both sides. 2x subtract 3x is negative 1x. On the right side, only the negative 6 remains. Now subtract 3 from both sides. Negative x equals negative 9. Finally, multiply both sides by negative 1, and x will equal to positive 9. Number 25 has fractions. We can do the work with the fractions in the problem, or we could remove the fractions as our first step. That's what I'm going to choose to do. I'm going to multiply all terms by the lowest common denominator, which is 4. Think about what happens when you multiply everything by 4. If you times this by 4, then the 4 you're timesing by will cross-cancel with the denominator, leaving the 5x. Now this piece. 4 times 1/2 is 2. Now multiply this one by 4. That's 4x. And then this one. This becomes negative 2. Let's collect x terms on the left side by subtracting 4x. 5x subtract 4x is 1x. And on the right side, there's only the negative 2 left. Now subtract 2 from both sides. X equals negative 4. Number 29, I see the parentheses here, so I'm going to do some distributive property. X plus 8 equals, and then 2 times x is 2x, and 2 times negative 2 is negative 4. Notice on the right side an x term here and an x term here. That means we can do combine like terms. So x plus 8 equals 2x minus x is 1x, and the minus 4 is still there. Next step, I'm going to subtract x from both sides. X subtract x makes no x's, and on the right side, x subtract x makes no x's. At this point, there are no variables remaining, and we have the statement 8 is equal to negative 4. That's a false statement. This problem has no solution. There is no number that could be substituted in place of these x's that would make the left side of the equation ever be equal to the right side. Next, number 33. This equation has fractions. There's even a variable in the denominator, so we have to be careful of our domain restrictions. And there are different ways to solve a problem like this. This has the look, however, of a proportion. One fraction on the left, one fraction on the right. One way to solve a proportion is called cross multiplication. So I'm going to multiply this diagonal together, and that's going to be equal to, and then I'm going to multiply this diagonal together. So that first diagonal is 2 times the 5x plus 4. That will be equal to, and now that other diagonal is 3 times the 5x minus 4. This is not the only way to do this problem. It's simply one way. In the next step, some distributive property. This is 10x plus 8 equals 15x minus 12. In the next step, I'm going to subtract 15x from both sides. So 10x subtract 15x is negative 5x. And on the right side, there's still the negative 12 there. Then subtract 8 from both sides. So negative 5x is equal to negative 20. And finally, divide by the coefficient of negative 5. So x is equal to 4. Because the original problem had a variable in the denominator, we need to check to make sure that that 4 is in the domain. So we're going to plug a 4 in there. Make sure this denominator does not turn out to be a 0. 5 times 4 is 20. 20 plus 4 is 24. That's okay. It's okay to have a fraction with a 24 in the denominator. Number 37. This equation also has fractions, and unlike the last one, it's not in the format of a proportion. It doesn't have a single fraction on the left side and a single fraction on the right. So I'm going to use a different technique this time. I'm going to multiply all of the terms in the problem by the lowest common denominator. Well, what will that denominator consist of? I can see from the first one that it consists of x minus 3, but I can see from this one the denominator is x plus 3. Those are different factors. Those aren't the same thing. Now over here, x squared minus 9, at first glance, this looks like an entirely different thing, but think about what this factors into. X squared minus 9 is the same thing as x plus 3 times x minus 3. If I'm going to create common denominators with x plus 3 and x minus 3, this fraction here already has that denominator. All right, let's multiply the first term by x plus 3 times x minus 3. Let's multiply the second term by x plus 3 times x minus 3. And multiply this last one by x plus 3 times x minus 3. When we actually multiply, some things are going to cancel out. Let's focus on this first portion. This x minus 3 cancels this x minus 3, leaving this. So 1 times x plus 3 is x plus 3. Now let's work on this middle piece. This x plus 3 cancels with this. Look what's left over. 1 times x minus 3. So that makes a plus sign from right here. And then x minus 3. Okay, now we have our equals. Let's do some work over here. Is anything going to cancel out? Remember how x squared minus 9 was just the same thing as this? So this will cancel out both of those factors. And what's left is the 10. By multiplying all the terms by the lowest common denominator, we've created an equation that has no denominators at all. Now we'll continue working on this. We can combine like terms. X plus x is 2x. Positive 3 and minus 3 cancels away to nothing. So we have 2x is equal to 10. Therefore, x is equal to 5. Now in the original problem, there were variables in the denominator. We need to check this in there and make sure that it's in the domain, that it doesn't create a 0 in the bottom when we plug it in. So 5 minus 3 makes 2. That's okay. Right here, 5 plus 3 makes 8. That's okay. And over here, 5 squared is 25. 25 minus 9 does not make a 0 either. So 5 is okay. Next, number 41. This is a lot like the one we just did. We're going to multiply all terms in there by the lowest common denominator. Well, what will be the factors of that denominator? This denominator is 2x plus 1, but this one's something different, 2x minus 1. So our lowest common denominator will consist of both of those factors. We need to multiply by 2x plus 1, 2x minus 1. Then right here, next to the 8x, we need to multiply it by 2x plus 1, 2x minus 1. And even the negative 4, that needs to get multiplied by 2x plus 1, 2x minus 1. When we multiply, some things will cancel out. The 2x plus 1 cancels the 2x plus 1. Look what's left, 7 times 2x minus 1. 7 times 2x is 14x, and 7 times the negative 1 is negative 7. Now there is a minus sign. There it is. Okay, now let's work on this piece. The 2x minus 1 cancels the 2x minus 1. Here's what's left. 8x times 2x is 16x squared. 8x times 1 is positive 8x. Do you understand why I have the grouping symbols around this? Because that all comes after that minus sign. I want that subtraction to apply to this term and to this term. Now we have the equals, and over on this side, nothing cancels out, so we need to perform this work. How about before multiplying the negative 4, if we do FOIL on this piece? Then we can multiply whatever we get from the FOIL by the negative 4. In fact, let's even handle this in 2 steps. Let's try not to do too much at one time. 2x times 2x is 4x squared. The outer product is negative 2x. The inner is positive 2x. Those cancel. And then 1 times negative 1 makes minus 1. In the next step, let's distribute the subtraction to both terms. And over on this side, distribute the negative 4 to both terms. So what we're doing is the distributive property. 14x minus 7 is how it begins. And then the negative distributes there, making negative 16x squared. The negative distributes to the 8x, making minus 8x. On the right-hand side, negative 4 times 4x squared is negative 16x squared. And negative 4 times negative 1 is plus 4. Let's add 16x squared to both sides with the intention of removing it from the right side. But when you add 16x squared to negative 16x squared, that makes no x squareds. So what will happen when we add 16x squared to both sides is it will cancel away here, and it will cancel away here. In the next step, let's combine like terms. 14x minus 8x combines to a 6x. Next, add 7 to both sides. 6x is equal to 11. And finally, divide by 6 on both sides. X is equal to 11/6. There was a variable in the denominator within the original equation, so we need to plug in 11/6 to make sure that doesn't cause these denominators to be 0. If it did, we would cross out that answer and replace it with the words no solution. Next, number 45. It has the same format as the ones we've been doing, where our technique has been to remove the fractions by multiplying all terms by the lowest common denominator. That seems to consist of 2 factors, an x and an x minus 3. So let's multiply the first one by x times x minus 3. Now multiply the term here by x times x minus 3. And this one right here multiply by x times x minus 3. There will be some canceling that happens when you do that. The x times x minus 3 cancels this one away, leaving the 3. Now we have our plus sign. Now let's work on this middle piece. The x cancels the x. What remains is 4 times x minus 3. So that's 4x minus 12. Now comes the equal symbol. Okay, and now this last piece. The x minus 3 cancels this away, just leaving the x. 1 times x makes x. Okay, now that the fractions are gone, let's continue on. I'm going to subtract x from both sides so that it's not on the right and it comes over on the left. So we have 3 plus 3x minus 12 is equal to 0. Now combine like terms. Because there's a 3 and a minus 12 on the same side, we get 3x minus 9 is equal to 0. Now add 9. 3x equals 9. Therefore, x must equal to 3. Because there were variables in the denominator, plug that in and make sure it doesn't cause any of your denominators to be 0. When you plug in the 3 right here and right here, look what happens. 3 minus 3 makes a 0. 3 times 0 makes a 0. You can't have 0 in the denominator. 3 is a restricted value. That does not solve the problem. And since there are no other choices of an answer, we say no solution. Number 49 does not have any fractions in it. I see some parentheses, so let's do the distributive property. That makes 4x plus 4. And we'll copy the rest down. There are x terms on the left side, but there's also this x on the right. Let's subtract x from both sides. 4x subtract x makes 3x. Next, let's subtract 4 from both sides. 3x minus ax equals 1. Now we need to combine like terms because there are two x terms and they're both on the same side, so they can be combined. Combine their coefficients. It becomes 3 minus a times the x, and that's equal to 1. To get the x alone, we want to divide by the 3 minus a. We have x equals 1 over 3 minus a. Okay, that's all of the straightforward solving equation problems. The next set are word problems. Number 59 says, find the dimensions of the room. There's some information given in the problem, and there's even a drawing of the room. The drawing looks like this: a rectangular shaped room. This direction is labeled with an L for length, and this direction is labeled with a W for width. We're told in a sentence that the room is 1.5 times longer than it is wide. So its length is 1.5 times its width. I've translated the sentence into an algebraic equation that models that sentence. We're told that the perimeter, the distance around the room, is 75 feet. With that information, we can find the dimensions of the room, which means find the length and find the width. The perimeter of a rectangle is twice the length plus twice the width. If the perimeter is 75 feet, the capital P can be replaced with the number 75. If the letter L is 1.5 times W, then the letter L can be replaced with 1.5 W. And then I'll keep the 2W. This creates an equation with only the variable W in it. We can solve for W. 2 times 1.5 makes 3W. Now combine like terms. 3W plus 2W is 5W. To get W alone, divide by its coefficient of 5. 75 divided by 5 is 15. We have figured out the width of the room is 15 feet. We now need to get the length of the room, but we had made an equation that modeled the length in terms of the width. It's 1.5 times W, and W is 15. So to get the length, we can go 1.5 times 15. And that result is 22.5. So the length of the room is 22.5 feet. Next, number 61. 61 is a problem about driving a car on a trip, and the question asks, how long will the entire trip take? The story goes, suppose you are driving on a freeway to a town 150 miles from home. Let's make a sketch of that. I'm going to have this dot represent home, and then draw a line segment to another dot which will represent the town. Remember that we're told that this entire distance is 150 miles. The story goes on. After 30 minutes, you pass an exit that you know is 25 miles from your home. So the car is traveling around the freeway, and after 30 minutes goes by, there's an exit. I'm going to put a dot for that. That's the exit. And we're told that that exit is 25 miles from our home. We're also told that it takes 30 minutes to travel that distance. We can also use the information we have to find our rate of speed. There's a formula that relates distance, rate, and time. It's d equals r times t. If you rearrange this formula to find the r, it becomes r equals d divided by t. The distance from the home to the exit is 25 miles, so we could fill that in for d. and the time that it took to drive the 25 miles was 30 minutes. Fill that in for t. And then we can simplify this fraction to 5/6 miles per minute, or we could do it as a decimal. Every minute we can travel 5/6 of a mile. We know our entire trip is 150 miles, so how many minutes would it take to travel that distance? Let's rearrange the formula again to find the time. It would be d divided by the r. And for our distance, fill in that the entire trip is 150 miles, and that for the letter r, our rate of speed is 5/6 miles per minute. With a calculator, we can easily go 150 divided by the fraction 5/6 to get the result. It is 180 minutes. Number 69 is a word problem about measuring the height of a building. The problem states, suppose you wanted to measure the height of the building shown below. To do this, you measure the building's shadow and find that it's 50 feet long. You also measure the shadow of a 4-foot stake and find that it is 3.5 feet long. How tall is the building? Let's duplicate the sketch that's in the book. Here's the building. Here's the ground. Here's a 4-foot stake pounded into the ground. When the sun is up in the sky, the rays of the sunlight will come down, clip the edge of the building, and continue on down to the ground. This will be brightly lit, but this part of the ground here will be in shadow because the rays of the sun are blocked by the building. So along the ground here it'll be darker, that's the shadow. The rays of the sun will also come down from the sky, clip the top of the stake, and continue down to the ground. This will be brightly lit, but this part of the ground here will be the shadow of the stake. Please notice the similar shaped triangles involved. We're told that the length of this shadow is 50 feet. We're told that the stake is 4 feet tall, and that the shadow cast by the stake is 3.5 feet. With that information, we can find the height of the building. Let's put an X on that. These are similar triangles, so from geometry class, we know that there's a proportional relationship between corresponding sides. The height of the building can be compared to the shadow of the building if the height of the stake is compared to the shadow of the stake. This proportion can be solved by cross multiplication or by multiplying both sides by the 50. So we'll get x equals 50 times the 4 over 3.5. Let's take a calculator and work this out. And the result is 57.1 feet. If a stake that is 4 feet long casts a shadow that's 3.5 feet long, then the building would be 57 feet long if its shadow is 50 feet long. Number 73. The problem reads, to get an A in a course, you must have an average of at least 90 on 4 tests, each worth 100 points. Your scores on the first 3 tests are 87, 92, and 84. The question is, what must you score on the 4th test so that your course average is at least 90%? So this is the first test score, the second score, the third score. We don't know the 4th score. Let's use the letter X to represent it. We want our average to be at least 90. The way that you average 4 tests that are each worth 100 points is to add the 4 scores together and divide by 4. Let's do that. We want that average to turn out to be greater than or equal to 90. Because if it is, we're going to get an A in the class. So we've taken the sentences and modeled them using algebra expressions, which we can now solve. We can multiply by 4 on both sides, which will cause the 4 to move to this side. And let's even add up those 3 numbers. That makes 263 plus x is greater than or equal to 360. Now we can subtract the 263 from both sides to get the x alone. And the result is 97. On our fourth and final test, we have to score at least a 97 in order to get an A in the class. Question 83 gives us the math formula for area of a triangle. We're asked to transform the equation so that the variable h is alone. In the first step, we can multiply by 2 on both sides. It becomes 2a equals bh. And then we can divide by b on both sides. We get 2a divided by b is equal to the h. So we have isolated the h. In problem 87, we have the area formula for a trapezoid. We're asked to transform it so that the variable b is alone. In the first step, we can multiply both sides by 2. We get 2a is equal to a plus b times by h. In the next step, divide by the h. 2a divided by h is equal to the a plus b. Once the h is gone, there's no need to have the parentheses around the a plus b anymore because they're the only thing on that side. In the next step, we can subtract the a from both sides. So 2a divided by h, subtract a, is equal to the b. Next, 91. A formula from physics class. And I forgot to bold it, but we're asked to get the m2 alone. In the first step, let's divide by the alpha. So we get f divided by alpha equals m1, m2 over r squared. In the next step, multiply both sides by the r squared. So we get f r squared over alpha, and that's equal to the m1 times the m2. In the next step, we can divide by mass number 1. And let me do that right up in this space. So we have f times r squared over the alpha and the m1. And that's equal to m2. The last question is a story problem involving 2 children using a seesaw. There's a drawing of the seesaw given, and there's even a math formula that applies to a seesaw. It is W1 times x equals W2 times L minus x, where W1 is the weight of one child, W2 is the weight of the second child, L is the length of the entire teeter-totter, and the variable x is the distance from the fulcrum where the first child sits. We're told in the story that W1 is 50 pounds, and we're asked to find x. We're told in the story that W2 is 75 pounds. And we're told in the story that the length of the teeter-totter is 10 feet. The one thing we don't know is x. That's what we're asked to find out, find x. So we've created an equation that we can solve for x. Let's do a little distributive property on it. 75 times 10 is 750. 75 times negative x is negative 75x. Now we can add 75x to both sides. This is 125x equals 750. And finally divide by 125. So x is equal to 6. The first child, the one who weighed 50 pounds, has to sit 6 feet away from the fulcrum. So if this was the teeter-totter that's 10 feet long, and that first kid sitting on this end, the fulcrum has to be kind of here so that that distance is 6 feet, and that distance is only 4 feet.